All right, students, hello. I want to let you know we're doing this 2.2 lesson. Of course, I have my book here. Been reading from the book. I've got my 2.2 lesson that we're going to do a video for. So, if you would sort of make believe you're in the classroom, and we'll just take it one step at a time. All right, so maybe you want to take some notes on this, okay? All right, here we go. Now, you may not know it, but this book came out not long ago talking about that America has got, or the American school is really in danger. 32nd illiterate and 32nd in the world mathematically. That's a little scary. You may have noticed in your book there is an example of a infinity. You ever been in a barber shop and seen a mirror, two mirrors? You look into the mirrors and you keep on seeing this image going back in the past. The idea of infinity is a really neat idea in mathematics. Of course, you may or may not be familiar with it. We have satellites that have gone out in orbit, Voyager 1 and Voyager 2, and they have gone out actually past the solar system into what's called interstellar space. And so, will they go to infinity? I guess that would be an interesting question for our study. So here we are. We're going to talk about subsets. And let me get, sort of right down to it. What we want to do is we want to recognize subsets and use this notation, this special notation right here. We want to recognize proper subsets. That's different than a subset. And we'll use this notation right here. So we'll talk about that in a moment. We want to determine the number of subsets in a set, and we want to apply the concepts of subset and equivalent sets to infinite sets. Now, we may not get to this number 4, but if we do, I just want to give you a little heads up on that. It's a math tattoo, okay? Of course, folks that wear tattoos, they're a subset of the population, right? Okay. All right, so what we're going to do is we'll do some note taking. All right, so let's do some note taking here, okay? 2.2 subsets. Okay. Now, um, here's a definition. Okay. Set A is a subset of set B. Set A is a subset of set B, or the way we can write it is A, watch this, is a subset of set B. Notice a capital letter, and I have this symbol. It almost looks like less than or equal to, but it's the subset symbol. Now, set A is a subset of B if what? If every element in A, is also in B. Okay, so let's do an example here. Okay, let me move this out of the way here. Here's set A. Set A is equal to 1, 2, and 3. Here's set B. All right, set B is 1, comma 2. Okay. Now, I want to know yes or no. Is A subset of B? True or false? Well, is every element of A in B? Well, no, because 3 is not in B, so that would be false. Okay, how about this? Is B a subset of A? Is B a subset of A? I don't know. Are all the elements in B also in A? And the answer is yes. So if all of those elements are in the other element, the other set, then it's true. So in other words, is 1 in A? Yes. Is 2 in A? Yes. So therefore that's true. All right, what about this? I want to know if this is a true statement or not. Is that a true statement, true or false? Well, how would I say that? I would say that A is not a subset of B. All right. Now we know from over here, A is not a set. A can't be a subset of B because we said it was false. So would that statement be true or false? Well, let's see. Is A subset of B? Well, no, it's not. So this means no. So yes, that would be true. So try to remember this. It's either true or it's false. There is no gray area. Okay? So keep that in mind. Now, new page. All right, now what I want to do is I want to go and I want to talk about proper subsets. Let me do this in a different color. Let's try that color, okay? All right, so proper subsets. Here's the key when you're talking about proper subsets. Has less members or less elements. Okay? All right, so here's, I'll just put a circle here. I got 1, 2, 3, 4, 5, 6, 7. Let's call that B. And here's A. 1, 2, 3, 4. A. Does A have less parts than B? If A has less parts, then we can say that this relationship proper subset applies to that. All right, let me give you an example. First of all, let me give you a definition. Set A is a proper subset of set B or watch the symbols. A is a proper subset of B if, okay, if, now what are my conditions? If set A is a subset, it's got to be a subset first of set B, and A is not equal to B, or the cardinality is different. All right, so Mr. Staples, give me an example so I know I'm on the same page. All right, here you go. A is 1, 3. B is 1, 3, 5. Okay? And I'm wanting to know what symbols you can put in here. What symbols can you put in here? Well, for one, could you put this symbol here? Is A subset of B? Well, I don't know. Is every element in A also in B? Yeah, let's see. I got a 1, and I got a 1. I got a 3, and I got a 3. Yes, A is a subset of B. But we're talking what? Proper subsets. So the question is the cardinality of A is 2, right? N of A is equal to 2. And the cardinality of B is 3, right? So can we say A is not equal to B? Yeah, A is not equal to B. So we can also say that A is a proper subset. Okay, I don't want any confusion here, so this is what you need to know. Whenever you hear the words proper subset, you're going to think has less elements or less members. That would be the easiest way to handle that situation. All right, now I'm going to pause and go back to my PowerPoint here. So hold on. Okay, so can you answer this question? That's a good question. Can you, let's see, um, well, write the subset or not proper subset. Okay, so I've got A and I've got B. Is A a subset of B? Well, 1, 1, 3, 3, 5, 5, 7, 7. A is a subset. Okay, now, is A proper subset? A is also a proper subset, and so we cannot write the second item right here, not a subset. All right, I know that this sounds like I'm talking Chinese here. Okay, let's see. Let's look at the next one. Set A. Set A is a letter in the word proof. A letter in the word proof. P-R-O-F, right? And B. Y is a letter in the word roof. R-O-O-F. Okay, so the question is A proper subset of B? Well, are all the letters in A in B? No, because P, the letter P is not in B. So that would be, you cannot write a subset. Now, is it a proper subset? No. So you could say not a proper subset. All right, I hope that didn't complicate things. Okay, so, just a little quick review. We talked about subsets. A is a subset of B. And then here we talked about proper subsets. And remember, has less is the key. Okay, I want to talk about subsets and the empty set. Subsets and the empty set. Now remember, the empty set has this, you could say that, or you could say that. All right. Well, let's say A is the empty set, and let's say B has two elements. Let's say 1 and 2, okay? Well, now, is A a subset of B? Well, since no elements in A are not in B, right? No elements in A are not in B, we could say yes. So try to remember this. I don't want you to really memorize it. The empty set is a set of every other subset except itself. All right, so let me write that in set lingo. For any set B, the empty set is a subset of B. Okay. Of course, there's an exception. Exception is except when B is the empty set. Okay, so basically speaking, the empty set is a subset of any other set. All right, so let's go and let's see, I got 1 minute, so I'm going to go to the new page here and I'm going to pause or just stop this video and then I'll do some more examples on this next page.